he suggested
Sorry.
skipping linear denoising and using MMT in nonlinear, which I tried, and I found for this image it seemed to work very well at tamping down the chrominance noise. I used mostly MLT sharpening to bring out the details in the arms of the galaxy. Then I separated the stars from the background image, and mindful of Alex's lessons of a month ago, I didn't do anything to the background after that. I just used that technique to saturate the stars a bit more, and then I put it back together. So that's how this came to be.
Excellent. You know, the core of the galaxy is very well resolved. That's a great job.
Yeah. I didn't answer the question. Why is this a favorite? Well, I'm still at the stage where the latest image I do is always my favorite because I learn more each time I do something. But this one, there seems to be so much in the data that I feel like I could go back to this image again and again, and there's just more. There's the little tracing of arms over here that I was able to pick up a little bit of, do some more with the HA regions in the galaxy. It just seems, I just enjoyed the amount of detail that I found, even if I'm not proficient yet at bringing it all out.
Great when it all comes together.
Yeah.
Oh, very nice.
Very nice.
Thanks.
All right. Well, thank you for that. That's a great way to start out. The next guy on my list is Randy Smith. Randy, are you with us?
I'm here.
Okay. Take it away.
Okay, let's see. That says this will stop others sharing the screen and share. So, uh-oh, that doesn't look right. I shouldn't have clicked that evidently. Okay. I go back here and start fresh with a screen share. Here's what I want. Okay.
Right.
Now, you know, when I bought this Red Cat 51, it was almost just say, okay, I'll get this, I'll treat myself to a toy and have fun with it. I had no idea what to expect. I've never had a refractor. I've had a C8 and now a C11. But I've been very happy with the Red Cat 51 images at 250 millimeter focal length. The clarity, the flatness of field, and just the detail you can get with this. And when you pair it with the 2600 color camera and its large chip, you can get a lot of stuff. And so we have all the way from the flame clear up through Orion. And these are 5-minute exposures, about maybe 3 hours worth. And it's shooting at f4.9. I've shot pieces of this lots of times. I'm sure everybody has, but somehow this one seemed to come together. And even though I really like the C11 and a lot of the images I've gotten with it, I really like this one, just how it all worked. And I'm very pleased with the quality of this. When you go in and you look and you say, when you're blowing something up that was shot in 250 millimeter focal length and it can look like that, and you can get this kind of detail, that seems good. So I'd have to say my first go with a refractor. I'm pleased with it. And it's a very complementary image scale to what you can get with the C11. So as many times as I've shot this or parts of it, to bring it all together, and I think this is a difficult one to shoot because you have so many colors and you have all this brown dust all around there, and to get all of that to come out and kind of make it work makes me happy every time I look at it. So that's why it's my favorite image. So,
Okay,
Yep,
That's
I
great.
think so too. Yeah, I'm really impressed with the amount of background detail that, in addition to the usual stuff that you see, there's so much stuff in the background there.
yes.
yeah, well, actually, the background is not dark here in this part of the sky. It's what kind of camera did you use once again?
It's a ZWO 2600 MC. So that's their
Oh.
color camera.
Oh, no wonder you got that. I use that too. Oh, isn't that a great camera though?
Well, I think it's a great camera. It's
Well,
you have to work awfully hard to saturate anything with it because it has really deep well depth on it.
yeah.
And it's very sensitive as well. Anyway,
Randy, did you use any filters with this?
this would have been the L enhanced filter. So I don't really use that L extreme on this just because at 4.9, I'm not sure you get all that much light through it. You can hardly see through that filter. It's fine at f2 or f1.9, but no, I'd use the L enhanced, and it gets that, as a tri-band filter. It's going to bring through about everything that there is there. You're even getting some of this reflection around the Running Man with that filter. So anyway, any other questions? Or?
That's a keeper.
How many?
Spectacular.
How many? How long of exposures? Like how many subs times how many minutes?
Well, their 5-minute exposures, about 3 hours worth.
Oh, 3 hours. You mean like, so 36 times 5.
Yes, that'd be about right.
180 minutes. That would be 36. Wow, you got that. You went that deep. That's
So yeah, it's I'm now setting up and just shooting all night. I'm totally automated now with the ASI Air. Although I don't have an autofocuser on this. This is just manual focus using the batten off mask that that's built into the Red Cats.
right. So would you
Does
have
the
to
Red
stop
Does the
periodically?
Red Cat hold focus pretty well? Or does
Well,
it change?
I'd say yes.
Okay,
I
so you don't get a lot of change with temperature?
have not. So I have not had I've had good focus on anything I've shot with the Red Cat. I'm tempted to go ahead and put a focuser on it. But it works well. It's very tedious to focus because it focuses like a DSLR lens. The focus is out on the end of it, and it is unbelievably sensitive.
Is it a metal tube? Metal tube OTA?
Yes.
So have you had to stop and refocus several times during
No.
Oh.
I focus. The routine is you polar line the mount, which I always do because it's so easy in the air. It's a 5-minute deal to polar line every time you set it out. And then I go to a bright star and focus with the B mask and go to my object and get it framed up the way I want it and hit go. There's no refocus.
So you just let it go straight through for the 3 hours then?
Yes, that's right.
Okay. Wow.
Excellent. All right.
Anyway, it works. And like I say, I keep coming back to this one just because I like it.
It's
All right.
beautiful,
Thank
Randy.
you.
Thank you.
All right.
All
Alex,
right,
Alex Warnow, you're up next.
Okay.
Are you with us, Alex?
Yeah.
Okay.
Getting through it? Good. Let's see here. We'll share a screen. How's that? Looks like
Good.
an
You got it.
Okay, well, this is one of my favorite images, and I thought I'd use this one because it's a narrowband image, and I wanted to talk about one way I use narrowband filters to get something approximating true color. So this is SHO filters, and this is NGC 2237. It's a piece of the Rosette Nebula taken through a CDK 17, and so it's not the whole Rosette, as you might well be able to tell. Okay, so if you all recall, our broadband filters are blue, green, and red. And the narrowband filters most of us work with are hydrogen alpha filter, which is sort of, it's red, and a sulfur 2 filter, which is even redder. Actually, it kind of hangs almost into the near infrared. And so that's an issue. And an oxygen filter, which is teal in color, maybe a little bluer than it's actually shown in this illustration. Then there's one we seldom shoot, and that's the hydrogen beta. But as I'll explain, you don't have to shoot hydrogen beta to know how much hydrogen beta you have and where it is. So the objective we're going to try to talk about today is taking these narrowband filters and somehow mapping them into broadband RGB space so that we can display them like all of our other images are displayed as red, blue, and green. This is a sense of what the sRGB color space is like, which is what I work in. And I think most of us probably do. A few people work in a bigger color spaces. But if you're going to present things on, on Astroband or anywhere publicly sharing, you probably have to get into the sRGB space. So these are the colors from blue around to red that are part of the natural spectrum. These colors here don't exist in nature. Our brain makes all of these up. So in our mapping, we're going to try to avoid mapping anything into colors that don't have any physical meaning, because I'm trying to get to what I would call true colors. And one of those true colors, or one of the color palettes that's most often used, probably grossly overused, is something called the Hubble palette, where hydrogen is mapped into green as opposed to being in red. Sulfur is red and oxygen is blue. And hydrogen beta is nowhere to be seen. Alternatively, this is the mapping that I commonly use. It's not the only one. But hydrogen alpha, well, let's start here. Sulfur is dead red, right in the middle, and that's there. Hydrogen alpha is a little bit more toward the green. That's what it is here. It's just shifted over a little bit. So this may be difficult to resolve from the sulfur color-wise, but that's where we're going to put it. And oxygen is that teal color, and hydrogen beta is dead blue, right in the middle of the blue, and it is calculated as about 36–37% of the intensity of the hydrogen alpha, which is pretty reliable number to use if you're shooting nebulae. Okay, so that's my true color palette. And then after I map my colors using pixel math in PixInsight to those colors, I then color calibrate the images using star colors. It's photometric color calibration is the name of the tool. And after you do that, it will shift these colors a little bit. But in the end, you have something that more or less resembles what the RGB equivalent of those narrowband filter should be producing. And that's basically what I wanted to tell you.
Excellent, excellent. Any questions for Alex? That was a lot of information in a short span of time.
So Alex, you have a formula for each of your color where you're mixing.
That's right.
Yeah, okay.
Yeah, I use pixel math, and
right.
For instance, blue has some amount of oxygen, some amount of hydrogen alpha, which is the hydrogen beta component,
Yeah.
and so on.
Thank you.
Good. Excellent.
Very nice.
All right, next up, Doug Sanders. Doug, are you with us? He was here, I thought. No?
You mean Doug
Right.
Summers?
I think he
No.
means you, Doug Summers.
Doug Summers, yeah.
Okay, sorry, all right.
Did I say
Share
Sanders?
my
I'm sorry.
screen. All right. Okay, can you guys see this?
Yeah. There it
Yes.
is.
There it is.
All right. So and let me see if I can get this out of the way. Yeah, all right. Okay, so I don't have anything nearly as complicated. I maybe have the easiest processing of all. I'm in one-shot color, and I'm showing you here sort of the internals of my PixInsight workflow. I'm just doing a straightforward linear processing set on this object. When I get to most of that is denoise, right? And so that's sort of the front end. I've got this interesting color clip that I do, which is related to my specific camera, because unlike Randy's camera and Paul's camera, I will saturate quickly. And so my exposures are short. All of these exposures for this image are 45 seconds. And at that point, even these brightest stars will saturate. And so I've got a little color clip that works on these stars to make sure when they go nonlinear that they don't turn all pink. But that's neither here nor there. Most of this work in linear is noise reduction, and then I use a mass stretch. And after that, I took and typically I will separate, especially for nebula, I'll separate the stars from the nebula. Do a little curves work, a little more denoise, some color saturation, and maybe a little degreen, and then I'm kind of done. I think in general, let's see, the reason why I like this picture, there aren't too many pictures where, you look at the object and you say, okay, well, the name of that object really represents, what you can see here. So I can think of a few right off the top of my head, the horse head, the monkey head, well, the cat's paw is about as descriptive as it gets. And I really like this. And I made this picture for a friend who works at ESO and is just cat crazy. And so I knew that she would love this picture. And of course she did. So it's a cool picture. I like it. And it's fun. So that's my picture.
That's great. And that was shot with the setup you normally use?
Yep. So that's Raza with a 183 MC Pro, one-shot color. This one was 379 exposures of 45 seconds, about 4.7 hours. And the stack has an average full width half max of 3.3. And the one thing I didn't mention about this, that since this is a low object, typically the one thing I'll do with these low objects is I'm usually forced to throw a little channel match on. And for those of you who aren't familiar with that, the differential atmospheric refraction down low will shift the blue and the reds slightly differently. And as a result, you can use PixInsight's channel match to sort of bring those colors back together. And that's probably most of the time for anything above maybe 30 degrees off the horizon, you won't need to do that. But for objects that are below that, you'll often discover that those channels won't align nicely, and then you wind up having to put them back together. So I did a little of that in this object as well.
Was this from CAC?
This was from CAC, yeah.
Yeah.
And I probably threw away a lot more than I saved. so because it's low, right? You're down in the muck there, and the Douglas Light Dome isn't very far away from you. So.
And the ones you threw away were just because of bloated stars, or?
Yeah, typically the full width half max. If those are bad, there's always going to be a few. My mount isn't the greatest mount, so I'll have a little bit of guiding issues. But for the most part, it's mostly bloated stars and full width half max out of control. So I'll get rid of those.
Great.
What mount do you use?
I use a CGXL. So that's supposedly their heavy mount, right? And it should handle 75 to 80 pounds. My payload is 53, so I'm well within the spec. But actually, I found out the last time I was at CAC, I've been using a dew shield as a light baffle, which I really don't need to do. And I decided this last trip that I would take it off, like the second to the last night I was there. And wow, did that clean up my guiding issues. So I think my days of using the that dew shield are over, especially at CAC. So I'll suffer with the dew if I get it.
I'm gonna try it with my refractor and retract I can't remove it, but I can retract.
Yeah, but you've got a nice stiff
Well,
dew shield. I've got this floppy
Oh,
plastic
okay.
dew shield, and the wind out there at CAC usually blows
Yeah.
about 3 to 5. And so that causes quite a wind sail, and I hadn't appreciated that until I took it off.
well, that's getting rid of the dew shield, cut your surface area probably not quite in half, but almost. I've quit using one for the same reason. I'm on a hillside, and I generally, there's some wind, and it's a lot better if I don't use the dew shield. I don't need it, not really.
Yeah, I was really surprised at the magnitude of that shake that I get as a result of that. I didn't
Yeah.
expect that. I thought there would be some, but I didn't expect as much as there was, and
Yeah.
dramatic difference with and without that shield.
All right, well, now we've all learned something to try new. Get rid of your dew shield.
Keep a hair
All right,
dryer, I
thank-
guess, huh?
Thanks, Doug.
Yeah. All right.
Okay, Tom Rolfsmeyer up next. Your favorite image.
Okay, give me a second, guys. I've got to get down to where I need to be.
M33.
Yes. Let's move it up a little bit. Can everybody see that?
Yes.
Yep.
Well, this is taken with my C11. I did use the L Pro filter and a 0.7 reducer, flattener, star zona, and exposures are 3 minutes, and I believe there are 30 separate exposures. The image itself was stacked using maximum DL, color balanced, a little bit of background noise reduction, and that was about it. And also the digital, I can't remember the name.
Development.
Dynamic digital processing.
Yeah, digital development or digital processing. And that's all I've done with this image. The reason I like it is because it shows so much of the nebulosity that's in this galaxy and the star forming regions all around it. And I really find it interesting to, dig down in, just go in deeper and deeper. If you go too far, of course, it gets a little bit fuzzy, but with only about an hour and a half worth of data, I don't think it's too bad.
And what was what filter did you use again?
And L Pro. So,
Yeah, it
What's your
seems
mount,
like-
Tom?
pardon?
What is your mount?
I have a Skywatcher EQR Pro. EQ6R Pro.
Thanks.
Guiding with that mount has been uniformly at about a half an arc second. I had one night where it was a quarter of an arc second with the C11, so
Nice.
it guides quite well.
Seems like that filter picks up a lot of the hydrogen alpha emission in this particular object.
Yeah, it really came out very nice. I was very pleased with it. I'm sure that I could improve it if I spent a lot more time with it. You can get a little bit better noise reduction and a little bit better depth of field. But this was one of those objects that I've taken many times with other equipment, and I thought, well, you know, it is galaxy season, so let's go for a galaxy.
Excellent.
So that's all I've got for you. Any questions?
All right, very good. And next on the list here is Tom Eby. Tom, are you with us?
Yeah. Can you hear me okay?
Yeah, we got you.
Good. Okay. Share the screen here. Let's see. Maybe I'm the only guy with a black and white photo. Anyway.
No, you're not.
Okay. This was taken last year, about a little more than a year ago. It's NGC 4651. It's a 11th magnitude galaxy in Coma Berenices. And the thing with it, it's called the umbrella galaxy sometimes because it has this long extension coming out of it, almost like a parasol. The issue with the galaxy is that the core area is extremely bright, whereas the rest of the galaxy, the outer portions of that parasol structure, are extremely faint. So it's a challenge to put it all together to represent the entire galaxy within range in one image. So what I did was I took 31-minute exposures to get the core. Those exposures integrated are shown in the lower right here. And then I did 5.2 hours of longer exposures, and those were 5-minute exposures. I think what it was, 36 or something like that, to get the outer portion and the fainter areas. And then I used a process in Photoshop. It's called selection mask. Basically, what you do is you have to accurately register both the long and the short exposure sets, so they're precisely registered to one another. And then you go in and take the information from the core area in the short exposure set and transpose it using layers onto the very same portion of the longer exposure image. So you preserve the detail in that core, and also you preserve, of course, the detail in the longer exposure set. So if you combine them all properly, then you end up with this. So this is the entire field. And I thought it came out fairly well because you still see quite a bit of detail in the core, and the extension is shown pretty well as the faint material off to the upper left there, and other galaxies in the background. And this was taken with a AISIG ST10 XME camera, monochrome, auto or self-guided. The mount was a Ioptron CEM70 encoder mount. And let's see, the telescope was the Ritchie Christian 8-inch. I was taken at f8. So that's why it required quite a few exposures to bring out the fainter regions. And the resolution on that thing was about 0.86 arc seconds per pixel. And I used CCD soft acquisition software to run the AISIG camera. and collecting images in FITS format. So that's about it there. Any questions?
Yeah, I
Great,
have a
I
question
think-
for you. So do you use PixInsight at all?
Yeah, pretty much that's all I use. Well, I use a combination of CS5 Photoshop and PixInsight.
Okay,
So-
because this HDR composition idea from PixInsight is supposed to work. I wanted to do something very similar to what you've done here. You did a fabulous job on the core of that galaxy, but I found that PixInsight's HDR composition did not work the way it was advertised to work. So this is a pretty fabulous job you've done on this galaxy.
Well,
I
thanks.
tried to do it on the cat's eye, exactly what you're doing, right? Really
Yeah.
bright core, really faint extent, and I could not get that to match in PixInsight. So that's a little bit of a bummer.
Well, you
I'm
might want to
surprised
look
by
up. Yeah, Jerry Lauderdale just published this technique. I've got a copy of it here. It's called compositing two different exposures with selection masks, and it's pretty simple, really.
in Photoshop, you mean?
Yeah, it's in Photoshop.
Yeah,
so you
right.
gotta
So
use
no,
that.
I'm a believer. I think you did a good job there.
Mhm.
The
So-
controls are not that complicated in PixInsight for their HDR composition, and
Hey,
I could not produce that same
Can
result.
you blow it up a little more?
Do what?
Can you
Blow it
blow
up?
it up a little more?
How much? Yeah, if I blow it up, there you go.
Whoops.
That's
You
just a
put it-
JPEG. It's not a TIFF image, so I don't want to blow it up too much. But
Okay, I mean, it looks like you've got quite a bit of detail. Yeah, this is like what Doug just said. You did a great job on that nucleus. It's
yeah, the nuke, like I
not
said,
blown out.
well, if you go back and the upper right image here is the long exposure bias. So it's just so burned in, burned in
Yeah.
up there. You can't. There's no way you can retrieve. If you used HDMRT or HDRMT on this thing, it would
Okay.
help a little bit, but you wouldn't be able to duplicate anything close to what this mask selection process.
Oh,
is.
actually, okay. You didn't use a combination of different exposures, did you?
Well, yeah, that's exactly what it is. The one in the lower right is, as I said, 31-minute exposures.
Oh,
Stacks.
okay.
That's this. That's my short exposure, and then this is the long exposure group. And
Uh-huh.
then using the mask process, I'm transposing this into there, perfectly registered, so everything matches down to the pixel level. And then you use it's a feathering process involved there as well, and a few other things. So it's not ABC simplicity necessarily, but it's really quite simple. It's not just one step. But HDRMT works pretty good on some objects, I found. It works really well, for example, in M82 to bring out a lot of that detail. But as Doug says, a lot of times HDRMT, it works sometimes, but other times it's not real great. Even if you select different layers in the wavelet selection, that can help. But usually then I have to use pixel math, blend the result, the HDRMT with your original and so forth. And the results can be variable. It can be good or bad. But this was
Yeah.
such kind of an extreme case that I needed to use a selection mask process to really pull it out.
So just for my own satisfaction here, Tom, do you really mean to say HDRMT, or are you talking about HDR composition?
Oh, excuse me. I'm talking about HDRMT.
Okay, because I was trying it with HDR composition, and
Okay.
that I thought that was the way that was supposed to be done. Maybe I didn't try it. Maybe I didn't use the right tool.
Hey,
Yeah.
I'll have to go back and look at that.
Well,
I did that composition, HD composition successfully many times. And it's really not that many times you need it, but I've had no trouble with it. The default values don't work well for me though, and I had to fish around to find out. what-
Interesting. Okay. Sorry, I didn't mean to sidetrack. Just
yeah.
clarification.
Yeah. So,
That's excellent.
but the key thing is that when you take the two sets, the long and the short exposure sets, you have to make sure initially that they're perfectly registered before you undertake this layer selection process. So that's no big deal if you're just doing it in one night. You just change your exposure time. But I like the ST10 XME, and I like black and white representations of galaxies because I think they bring out a lot of the nice structure and gradation and some of the dynamic range. And the ST10 XME camera, I think, is only I think it's 12-bit, as I recall. So it's not the most modern camera, but it's still pretty capable, even though it weighs a ton. You gotta have a pretty good system there to balance it out and carry it. But it's a good camera yet, even though it's considered obsolete. So that's it.
All right.
Beautiful.
Thank you. So, Paul Lorenz, you didn't send your name in, but you said you had an image.
Yes, I have another one of M101. Some of you have seen it kind of in the, let's see, I'm gonna hit share screen. Okay, let's see. Oh, now where do I? Okay, you see it yet?
No.
Oh,
We don't see your screen yet, Paul.
Okay. Let's see, how do I get back on? Okay. Right, here I go. All right, I hit share screen. Okay, then I got to hit the share button. Okay. Now, how about now?
Got it.
Yeah.
Okay. Well, this I think may be about the best shot I've ever taken so far, best image. This is M101. This was taken with an Astrotech 152. It's a triplet apochromat. Working at f6.4. It uses I use with it a William Optics large reducer flattener lens. So the original f ratio is f8. So it reduces it by 0.8. It's a 0.8 times the reducer flattener lens. So that means it's working at f6.4. And I used a ZWO ASI 2600 MC probe, one shot color. And this is 12 5-minute exposures. I took 3 hours a couple of months ago out there, out at CAC. I took three hours worth of exposures. Initially, I stacked all three, and it went awfully deep, but the whole galaxy kind of turned to soup. And I had this one image out of the bunch, and Doug already knows about this because we were going over the images. He was showing me that, what is that? I can't think of that function now, what that's called in Pixin site. Frame.
Subframe selector.
Yeah, subframe selector, that's it. Yeah, yep, that's it. And anyway, we kind of went over the ones that were the best. So I took more or less the 12 best ones, and then I restacked them. And like for example, all these H2 regions and through here, they're kind of soupy. Here they come out really nice and sharp. So then I did the basic steps of Pixin site. I did the original, or I should say the stacking, the weighted batch processing and all that. I didn't get to the finer. I'm just learning some of the very basic steps of that, trying to use it. So anyway, I experimented a little bit with the histogram transformation. So I was able to bring out the middle of it was totally drowned before, the center of the galaxy. Now you can see, if you blow this up a little bit, you can start to really see the dust lanes in here. It's still pretty bright. And I haven't been able to get the contrast to where I'd really like it. And I guess you're going to need a mask to do that. This is I did try using a mask, and it didn't. I guess it didn't take. There was that mask function there and I'm not sure if it actually did anything or not, but it seemed to have gotten a slight improvement. Anyway, I originally took 3 hours worth of these, and then I used the best hour. So this is 60 minutes of integration time here. And anyway, these outer arms here, this stuff over here, not to say nothing of these way down here, which appear to be extension of some of these brighter ones. It looks like they're kind of pushing out. And but Jeff got this really well, but he used many more hours and you can do that, of course. But anyway, the detail that I got in, well, in this, this was totally invisible in the 40-inch out at CAC. These outer arms, you couldn't see it at all in the 40-inch. And with 1 hour's worth of exposures, with a 6-inch, I got this. And there are several other galaxies in the field here. This appears to be a dwarf companion to M101, and I haven't been able to. It's not plotted on any star atlas or anything, so it could be a UGC object. I doubt if it's an MGC object. Some of these may be. Some of these other galaxies are probably more distant in the background. But anyway, these you can see, like this whole arm here is, not only did this show up, but it showed up with some detail in it. And you can see, you know what I did at the end? I was able to get it over to the Canon processing, and there was one sharpening function that I used there to try and bring that out. And I wanted to use that one frame that really turned out really well, and the others didn't quite do as well. A couple of them were in the ballpark with it, but not on the pitcher's mound. And for the seeing, just everything went right for 5 minutes, you know. And I was going to kind of use that as the gold standard, but with this subframe selector in the future, I plan to restack these and do a weighted version, which may give a better, and maybe do 90 minutes out of those and maybe go a little bit deeper just to get well, not so much to go deeper, but just to get a better signal to noise ratio over the background. But anyway, I mean, the detail here, I mean, even 10 years ago, this would have been unheard of to get an image like this out of a 6-inch telescope.
All right.
So
Excellent.
anyway,
That's a good rendition.
so
Oh, it's
here,
even better when you zoom out.
yeah, pardon? What was that?
It's better when you zoom out. You can see it, the whole field.
Yeah, the whole field. Well, I wanted to show you that too, to kind of show you all a couple of this one little companion galaxy that I'm a little curious about as well. The colors are a bit muted here, and that's something I have to work on yet too with that. And I can't seem to get any saturation out of on that one function. But again, just like what I say, this I should say I use that histogram function there to try and bring these out. But on a couple of occasions when I tried to get the contrast, the center just blew out while is trying to get the challenge is to get the sky background darker without blowing out the nucleus.
All right. So
All
we've
right.
got a couple more to go through. I think Kevin has one. Kevin, are you still with us?
Let me unmute here.
Okay.
This is going to pale in comparison to what everybody else has shown, so it's got a little explanation to it. Easiest analogy is back when I was in kindergarten, I was very proud to come home one day and tell my parents I had been admitted to the school band, playing the sand blocks. And that lasted for about a week or two until I sanded another kid and got kicked out of the band. So they were no longer impressed. So let me screen share here. This is from CAC from a couple weekends ago.
Wow.
And why it's my all-time recent favorite is because many of you know I came up against the wall with PixInsight, running out of patience on spending hours and hours trying to process. And before I sort of crossed the event horizon, never to return, I decided this past weekend to take one more look at AstroPixel processor. So after an initial refresher, which I did on an M101 image, this one from soup to nuts with AstroPixel processor and then some final polishing in Lightroom was 50 minutes worth of software time. And I'm pleased with that. I mean, that's much better than the hours I spent with PixInsight, and then I would get to a point when I was frustrated enough with the result that it wasn't satisfying to me. 50 minutes worth is about right for me.
That's deep.
Yeah, you did that in just 15 minutes?
Oh no, that's 50 minutes of post-processing. This was
okay.
29 5-minute exposures.
Okay, so that's about 2.5 hours.
Just under 2.5 hours, yeah.
Oh, okay.
And what's your equipment, Kevin?
I mean, that's
this was a 130 refractor with the 2600 one-shot color camera, no filters.
Oh, same one.
Same camera, yeah.
That I used.
Excellent.
Yeah.
And this was all done with AstroPixel processor?
All the front end and some minimal sort of post-processing was done in that. I'm still not, I like the front end because it seems very efficient. The back end, a little less enamored of, which is why I took it into Lightroom and did some of the final contrast, saturation, and some of the other things because I could immediately see the result.
Lightroom is great for that.
Yeah. I have to say my computer, though, it sounded like I was pulled up to a stoplight and somebody in the car next to me, like a Prius, was revving its engine constantly running the drag race. But other than that, the computer and I survived the experience.
All right. Well, I was going to go last here and share something unusual.
How do I end my share?
I can do that.
Okay.
That's a nice shot, Kevin.
Thank you. PixInsight no more for me.
You've given up.
I think so.
Hey, what was the one? What do you call that one again?
AstroPixel processor.
AstroPixel process. Is that free?
No, well, they have a free trial, which is what I did like a year and a half ago, and then it's basically $60 for a year, or you pay I think twice that and get a lifetime subscription with all updates.
Oh, okay, well, that's maybe if I get frustrated enough with PixInsight, maybe I'll go that route.
Yeah, but again, I think it's good on the front end, not as great on the back end. You can't do deconvolution. If I wanted to do masking or anything else, I had to take it into another program.
Okay, all right.
All right. So this is one of my favorite images from a long, long time ago. Back in March of 2002, and I had just gotten into CCD imaging. I had built a Cookbook 245 CCD imager and decided that wasn't good enough. So I bought a Starlight Xpress MX916, and I used it. I think this was taken with an old Stellar View ST80. But in any case, this was a pretty bright comet, a pretty large comet that I couldn't fit in the field of view. And so I did a mosaic, and I wasn't very good at combining those images, and it kind of came out the way you see it here, where it's obvious where the mosaic was put together, but I thought it looked kind of cool, so I kept it like that. So the camera, the MX916, as you can see here, was a really early on CCD camera with big 11 micron pixels and a whopping 752 by 580 pixels altogether. And that's the reason why I had to mosaic the thing to get the whole comet combined. And the MX916 was supposed to be a wonderful camera because it used this chip that had what they called interline processing, where you could read out the odd rows, odd columns, and then the even columns. And so what they had was some software that allowed you to guide with the even columns while you were imaging with the odd columns. And then halfway through, you would flip and you would guide with the even columns and image with the odd columns. And it took twice as long to get an image of anything. And of course, it was just a mono camera, so you had to have a filter wheel. So I ended up doing a lot of just mono imaging with it. But one of the reasons it was became my favorite image was because the NASA museum in Washington had put out a call for amateur images. And so I submitted this image to the Air and Space Museum, and they put it up on a display for about 6 months, somewhere back in the back of the display there. There was a little kiosk that had images from different amateurs, and so it was up there for half an hour. I don't know if they still do that or not, but that was the first time I ever got an image published anywhere, and so I immediately became one of my favorite images.
Excellent.
All right, so I'm going to stop sharing there. If there's any questions or comments, we're about at an hour. Anybody else?
Greg, I was going to ask you, you had the MX916. I had one of those way back when too, and it was a very sensitive camera. It was a great camera.
Yeah.
Did you use it with I had a module it was called Star 2000, and it was the unit that connected between the camera and your mount computer,
Yeah.
so it allowed you to do the alternate guiding. That was actually pretty slick.
Yeah, it worked, but you had to spend twice as much time to get an image, because otherwise you just had the odd or even columns until you got the whole thing put back together.
Well,
the guiding, if I remember correctly, the guiding wasn't great. It worked, but
that was a long time ago.
Yeah, it was Starlight Express's answer to SBIG with the built-in guiding chip. So
right.
I'm glad to hear somebody else had one of those.
Yep. Greg, do you mind if I show one?
Sure.
Okay, thank you.
This is LAD.
Correct. Yep. Hi. I have to figure out that. Okay. I hope I'm sharing the right screen. Okay. So this is an image that I took last year. Greg, you're currently in the San Francisco Bay Area, which is where I used to live. And as you mentioned about the eclipse last night, there were clouds. That was a
Yeah.
recurring problem with trying to image in the Bay Area.
Yeah.
I originally was trying to do a mosaic of NGC 7000, which mosaics are always one of my challenges because I shoot these and trying to get them to come together. But the big problem in the Bay Area was that I could shoot part of it and then the skies would change and then I couldn't finish it. So I'm hoping to reshoot it all now that I'm here, which, you know, as you can see, I also have a broken hand at the moment, so I can't lift my telescopes over the last month where it's been nice and clear. I haven't been able to use it. So I'm looking forward to the observatories out at CAC once those get built. But so this is just a little piece of NGC 7000, which Alex also put out an image of this area recently, just a couple of days ago. And I just like it for artistic reasons. I just think it looks nice. This was 6 10-minute exposures using the L Extreme or the Optilong L Extreme filter on a ASI 2600 MC camera as well. The mount is a I should know this. Astrophysics 1100, and I think that's about all that. But I was trying to arrange this. This would have been a 6x4 matrix, and I just never had a chance to finish shooting all of the stuff. But I just liked this one area of it, and I hope to readdress it here soon.
All right.
That's great, lad.
Very good. Very good.
Very nice, and it's always fun to go back and pick up the rest.
Yeah. Okay. Thank you.
All right. Thank you.
Before we close, Greg, my daughter
Yeah.
in Chicago, who of course didn't see anything last night because of the clouds, sent me a cartoon that, if you don't mind one bad word, I'd like to share.
Do it.
Nope, that didn't work. Hang on.
It did.
Here.
It was up there for a moment.
Got it now?
Yeah. That pretty much tells the tale.
That's cute.
All right. Well, thank you, everybody. I think this was a good way to share where everybody take about 5 minutes and pick one of their favorite images. So maybe we'll do this again sometime in the distant future. Again, next month, we're going to talk about PixInsight. And Casey hasn't actually told me what his exact topic is going to be, but I'll publish that as soon as I find out. And again, the challenge for July is going to be either M16 or M13. And so be thinking about how you want to present that or how you want to go about getting it, or maybe you already have the data and you're just going to do a new process on it, but we'll look at that in July. So thank you, everyone, and I'll stop the recording.
I'll be at the Grand Canyon then. next month.
Okay.
Good night.